There we go. It's on now. Okay. So I'll just say, what is the research question? Is the mean age of death different than the mean age of death for any of the three categories? Okay, so who wants to do the next one?
So the null and alternative hypothesis. Is that the next one?
Yeah.
Yeah.
So the null hypothesis is all means are equal. The alternative is one or more means are different from the other.
Perfect. Okay.
Next one. I don't know.
I can do it. Okay, so number 2, it says collect the data. So it says describe the data collection procedures. Is it the rule? Wait, hold on, sorry. Okay, so the rule is if the largest variance is not 4 times the small variance, then you say that they're equal.
For describing the data? Is that what you're supposed to do?
Wait, is this the... Okay. Oh, okay, so let's see. Hold on. Oh, it's just collecting data from the 3 different types of writers, right? You don't really know.
Mm-hmm.
Yeah.
Yeah, like we don't know how they did it, but
I just put random writers were chosen in 3 different writing categories.
Yeah.
And their age of death was recorded. Because that's kind of inferred in the question, I guess. So, right. Next question says describe the data, and it says in a short paragraph use summary statistics to describe the data. And then after the paragraph, insert an appropriate and well-labeled graph. So I'm not really sure what they're looking for here. I just put the variance of group 1 is 170.342 for the novelists. Variance of the poets was 190, and the variance of group 3, which is the nonfiction writers, was 1.98. 198.723. And then wrote that the variances of the groups are close enough that we can equal, and then copied and pasted the QQ chart or plot onto my thing. I'm not sure if that's what they're looking for, but that's what made sense to me.
so for the summary statistics, it's the sample size for each. And then I think the mean and the standard deviation.
Mm-hmm.
I want to say, yeah. And so when you go into SPSS and let me see. I'm going to go into it so that I can remember how to do it exactly.
So I still have it up.
I think it's in the same data collection or whatever. You just did the variance instead of the other ones.
Yeah.
Yeah, well, I was trying to I guess it was like what the rules were is what I was going by to determine whether or not we would do a test. That's why I was like, okay, I'm not sure what they're looking for, but this makes sense to me. So looking for the mean, what do we looking for? The
they're looking for the sample size, so N for each.
So basically we just want like a copy of this chart. And for group 1 is 67, 32 for group 2, and 24 for group 3.
Yes.
And then We're wanting it for all three groups.
Yeah,
Mhm.
yeah, you want it for all three.
Okay, so then the mean for group 1 is 71.45. The mean for group 2 is 63.19. The mean for group 3 is 76.88. Then,
And always remember
Do we
to
want-
use 3 decimal places.
yeah, but it doesn't give us 3 decimal places. It only goes to 2 on the charts. So
Oh, okay. Yeah.
I'm just reading off the chart right now. Standard deviation they want of each group, or did we just want the one like of the groups combined? Can't remember how they want it here on this one.
Of each group.
Okay, so the standard deviation for each group, 13.052, group 2, 17.297, group 3 is 14.097,
Yep.
then
It's just those 3.
right.
Okay. And then you do the graph. Okay, so the next one, make inferences. What type of hypothesis test is appropriate? And that would be the ANOVA test.
Go figure, because we're learning about the ANOVA test.
Yeah, exactly.
Whoa, mind blowing there.
I know, it's crazy.
So, what are the requirements for this test? The data are normally distributed for each group. Note that the requirement is not the same. Sample means are. That's important. It's just that the data is normally distributed. Just make sure that they're normally distributed, and make sure this assumption is met, and that we have to do a QQ plot and make sure they appear normal, which they kind of do if you squint really hard.
Yeah.
Like-
Yeah.
The outliers are a little wonky, but overall it looks like it.
And then do we also have to compare the variances too and make sure it's not 4 times, like
Yeah.
biggest,
Yeah.
Yeah.
4 times larger or whatever?
Yeah.
Which
So
I gave
most of the time
before.
we assume.
Okay.
I gave the variances before, and the biggest one isn't even twice as much as the smallest one. So.
Yeah.
Okay, so we're on C or D?
See?
Okay, are the requirements met for this test? Explain. This will require plots and simple calculations. So according to the QQ plots, they look approximately normal, even though they're not perfect. But yeah. And like we said, it's not 4 times as big, so.
Yeah.
All right, so then D says compute the test statistic, which is F, which equals 6.563.
Perfect. Is it mine? Oh, yeah, it is.
Yeah.
State the degrees of freedom. So 2 and 120.
Perfect.
The p-value is, and compared to the alpha, is 0.002, and that is significantly less than 0.05.
Yeah.
Yeah.
Okay, so it says make a decision. Do you reject the null hypothesis or fail to reject? And you reject the null hypothesis because it's less than.
And so then present your conclusions in the form of an English statement. which I wrote, we conclude that the female poets do indeed die at different ages than other types of female writers, just because they pointed out in the thing that it was females that they were researching.
Yeah, perfect. Okay, so take action. With further study, we find the poets die earlier than the novelists and nonfiction writers. What significance can you conclude from this? So there was a quote in the beginning that said poets die young because they're restless. So, I mean, I don't know, but I feel like poets can sometimes be more self-destructive because they look inward a lot for their writing. I don't know. That's what I said.
That's good. I didn't even think about that.
Yeah, I was just like,
That was-
don't be a
It
poet
was
because
just
you
like,
die young.
Don't be a poet.
Poetry kills, man. Poetry kills.
Cool.
Cool.
We go to the exam.
Quiz.
Yes, I did terrible on this.
I hope I got. I felt like I did okay, but some of them I'm like, oh, I totally don't know if this is right. So, anyways, let's see.
Did you guys take the quiz or did you just write it down?
Oh, I forgot it's the quiz too. I just wrote it down.
Yeah, I just wrote it down. I guess we could just take it together. Are we going to take the lesson 14
Oh, wait.
quiz?
Yeah, we have to take
together?
the lesson 14 one. Yeah, that's right.
Oh, should we do that one first?
Yeah.
I think
Okay.
since we just went over that.
Sorry, we're getting
I know.
excited.
Getting ahead of ourselves.
I can't wait for this test. I just couldn't.
I know. I'm so excited.
Just the anxiety of just wanting to get it done, right?
Yeah, that's what it is.
Okay.
Okay.
Oh my gosh. Okay.
All right.
Okay.
Okay, so hold on, let me. No.
I have so many different SPSS things open. It's like crap. Which one's which?
Mm,
We just start with question number 3.
yes, my screen just went black and it's loading SPSS.
Yeah, it's a beast to put together.
Yeah. Okay, there we go. Come on. Someone else can start on question 3 if y'all are ready.
Okay, I can do it. This is in an ANOVA hypothesis test. We reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. True or false? That's true, right?
Yeah. Okay, so I can do the next one. It says, what requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. Sample means are all positive. Data in each group are normally distributed, and variances are equal in each group. Is it all 3, or is it just the last 2?
I thought it was just the last two.
I think it's just the last
I
2.
think
I thought
I don't think they can be negative though. I think it did say
They
something.
can't be negative, but I don't know if that's a requirement.
It's not a requirement though. It did say that, but
It
it's not
was-
a requirement. So
Yeah, like
maybe
it
just the
was.
last 2.
Let me
Okay.
see. So that's just a characteristic. It's not one of the requirements.
Yeah.
They tried to out on us.
Oh, okay. Is it my turn? Okay, to check if each group is normally distributed, do the following. Construct a scatter plot of the data in each group. Construct a histogram of all the data. Construct a QQ plot. So the QQ plot, right?
hmm So with question 6, we assume the variance in each group is the same if the following happens. The simple variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample. Each group has the same sample size. It's the largest variance is less than 4 times the smallest variance.
Yeah.
Because I always remember there's 4 involved with the ANOVA test. There's
Yeah.
4.
4. Just remember that. 4. Okay. Okay, Kara. Oh, I think something's wrong with hers.
Yeah. That's what I was thinking.
Like she's not responding. What's happening? Okay.
Can you hear me?
Yes, there you are.
Sorry, I was like, did the whole question, and I'm like, Key, what? Okay. Okay, sorry. It says an ANOVA hypothesis test is equivalent to conducting independent 2-sample tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, and 2, 3. How many pairs are there when there are 4 samples? I have no idea. 4?
I had to write this one out. So you have
Yeah.
1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and then 3, 4. So there's 6.
Oh, okay.
At least
Oh.
according to when I wrote it out.
In my head. 1, 2,
Oh, that makes
1, 3, 1, 4, 2, 3, and 2, 4, and then 3, 4. So 6.
sense. Yeah.
Yeah.
Okay.
Okay, good. I'm not losing my mind.
Okay, soccer shoes.
Okay. Charity?
I think your turn. The data in soccershoes.save help determine how the design of a soccer shoe affected the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 50 centimeters up from the ground. Accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Use this scenario above to answer the next 5 questions. So let me get it opened up real quick.
Okay.
What is the smallest variance? So let me bring that up. Okay. A, it's 7.358. For B, 29, so that one's bigger. For C, it's 27.208. It's smaller than the D is a lot bigger. Okay, so So it's C 27.208.
Okay, so on SPSS, this is the one where you do the ANOVA, right?
Mhm.
Okay. So you go to one-way ANOVA, but then you need something for the dependent list and the factor.
You need to do an automatic recode first.
Oh, that's why I didn't do that.
So for this, I did what they had us do in the book, which was go to is descriptive statistics and then explore. Just for the variances, that's what you need to do. To put all of that.
Wait, what'd you say? Sorry, my thing.
You go to analyze in the descriptive statistics and then down to explore, and it for the 3 different groups. Once you open up explore, it'll in the dependent list you're going to put age, and in the factor list you're going to put type, and then push OK.
Type, okay. I don't see either of those on mine. This is the soccer shoes, right?
Analyze down to, oh wait,
Because there are 2 that we have to take.
yeah, so it goes analyze down to descriptive statistics. Sorry, I was trying to do it in the wrong one. And down to explore, and then it'll be kicking accuracy as the dependent and footwear as the factor.
Oh, okay. Okay. I was like, what?
I brought up the poet one, and that's why. I was like, wait, I thought I closed this one out already.
Which
But
one's the dependent list again?
the kicking, so you want like
That's what I
basically
thought.
your results is the dependent and the factor is the different groups.
Okay. Okay, that makes sense.
Yeah.
All right, so
And then you push OK, and then you'll get your list of all of that.
okay, the minimum variance.
And then you have to like just keep scrolling. Kind of annoying, but it works.
Okay, and then the variance is just in all the different, like A, B, C.
Mm-hmm.
Okay.
Yeah, so you can see like where the variances. And they have it listed for each group underneath. Yeah, the letter. Right
Okay.
in the middle where it says variance.
Yeah, it's just below median.
Yeah. And then
Okay.
group C is the one that has the smallest, just barely smaller than group A. So,
Yeah.
So we just put that in, that's the answer.
yeah, which is 27.208.
08. Okay.
Excellent.
So the maximum was like 53 point something.
Max 53.158.
Whose turn is it again?
I think it's mine.
Yeah, I think it's yours.
Yeah, I think so.
So I'm pretty sure the test for equal variance is satisfied because 53 is not 4 times higher than 27.208.
No, it's not even 2 times.
Yeah.
So last time I checked it.
Yeah, that's okay. Okay.
Is it my turn?
I think it's my
Yeah.
turn.
Oh,
I
okay.
know. Is it your turn? I don't know.
I don't know.
I'll just
I
go.
think
Oh. Okay, you just do it.
Okay. Okay. Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Okay, so we got to do that.
so. If you just scroll down, you see it. It's still in the one that we have up. It's just at the bottom.
They look normal to
Can you hear
me.
Yeah.
Yeah.
All right, so
Did you guys get normal QQ plots?
Yeah.
Yeah.
I'm just trying to bring up the other part of it, but it's not letting me. Okay, understanding.
Did you guys all get it? Are we ready for the next one, or just are we waiting for something?
Oh, I think we're ready. I just
So I just did the question 12.
Yeah.
So
How do you get
to
rid
do
of
that,
the box?
I just highlighted it, right clicked it, cleared it.
Uh-huh.
Because I performed the test before with the socks in there, and then I just performed it without it.
Uh-huh.
So there is a difference. That is interesting. And the p-value goes up.
Oh, okay.
It goes from 0.081 to 0.309.
So you just like highlighted all
All the socks,
101
and-
to 120 or whatever?
yeah, and then just deleted it.
Okay.
Because I had taken the test, I'd done the test before with the socks,
Yeah.
and I did it without it. The p-value goes up, but the F statistic goes down.
Okay, so I got a point 309.
hmm
There you go. And then the F is 1.216.
That's what I got.
Okay.
So what is it? Sorry,
Okay, so that's what the p value is afterwards, and it's 0.309.
okay.
Wait, what? The test statistic for oh. Are you guys ready for 13?
Yeah, I think so. Wait. Yeah. Oh, I can do 13. It says the test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left? The F statistic, which it should be the right, I think. It's the right tail, right?
Yeah.
Okay, who's got number 14
Uh, I could read it. So it says researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the data, the type, the calories, and the sodium level. Their data is valuable in that file. Use the data file to answer the remaining questions. So it says, let's examine the calories first. Construct a QQ plot for the calories for each of the 3 types of hot dogs and compare the variances to determine if these assumptions to be omitted have been met. So we can do all that first. So let's see. Did you guys get the QQ plots up yet?
Yeah.
Okay. So they look pretty normal to me. Nothing too out of the ordinary. So let's see. So which one? Oh, I didn't look at the variances. Hold on. The variances look like they're normal too, to me.
Yeah.
So would you just say A, assumptions have been met?
That's what I got.
Okay. Cool. Who wants to do the next one?
I'm having a problem trying to get it to do my ANOVA test because it won't bring up the type for me to put.
Did you do an automatic read code?
Do we need to do that here?
Yeah, you need to do an automatic read code. So that way you have the meats, the different types of meats grouped together.
Okay. That's why. I was like, why am I not able to do this? It was driving me nuts. Okay, now I should be able to do it. Couldn't understand why it was doing that to me. Okay. Calories and Okay. Read the question then, or
Sure.
are we ready? Okay. So question 15 says run an ANOVA test to determine if the mean number of calories for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 50, that F is 16.074 and that P equals 0.000 with a level of significance equal to 0.05. What conclusion can you draw? So it's 0.00, like that's significantly smaller than 0.05.
Mm-hmm.
Sufficient evidence. To claim that at least one, okay, we have sufficient, one of the hot dog types has a different mean number of calories than another. That's
Yep.
what we should have.
Where is it?
It's the last one there. We have sufficient evidence to claim that at least one of them.
Okay. Whose turn is it to read? Or
Mine. And I'm looking. To do the QQ plots for each one.
Um,
I feel like they look the same.
yeah, I think they all look like they're normally distributed.
Yeah, because that's what I got. So I think it's the first one. The assumptions have been met. Because the smallest variance, the largest variance isn't 4 times.
Yeah, no, it's okay.
yeah. Okay.
I'm wondering.
So did you guys get 0.179 for the p-value?
Yes. At least that's what I got.
Okay, good.
Let me look at that. I'm just looking at because it says there was like a possible problem. I'm wondering if we got that last question.
Wait, what?
Like maybe look at the question in 17 says despite the possible problem with the QQ plot for poultry, to use the ANOVA. So does that mean like the question before maybe they aren't normally distributed? Because if you look at it, that first one looks like it might be skewed more towards one side. Or am I just looking into it farther than I should be again?
Honestly, it could go either way at that point in time. We could either be looking too hard at it or not hard enough.
Yeah. So I'm like, wait. It just makes me go back and question that other because of that.
Yeah, I mean, they're not perfect, but in every other question that we've ever done, it's like, they're not perfect, but we'll assume that they are.
Yeah. Yeah, that's why I was like, oh, okay.
I feel like they're
Take it
approximate, so, but I don't know.
Yeah. Okay.
We'll see, I guess. Okay, I can read the last one. It says, what conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? Use a level of significance of 0.05. So you would reject the null, right? Do you have sufficient evidence to claim
Well, I can't hear them. It's not working, but I can stop it.
that one of the hot dog types has a different mean sodium than the other?
Well, I tried to message them on chat.
The p-value is higher than the alpha level.
Oh,
Yeah.
That means we should fail to reject.
oh, sorry. Okay, yeah.
The p-value, what did you guys get for the p-value?
0.179.
Oh, okay. I see where it is now. I was looking at the wrong number. Okay. Yeah.
I hate that.
So it would be you do not have sufficient evidence to reject the claim.
Yeah, I don't know if that would work.
Is that it? We do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean sodium.
Yeah. It's worded so weird, but I think
Yeah, it's like to reject the claim.
have sufficient evidence to reject the claim. Yeah, because we're not rejecting the null. We're
Yeah, we're failing.
going with the null.
Yeah.
Which is like, wait. Let's make it as confused as we can.
Seriously. Yeah, I'm pretty
Pretty
sure
much.
that's right, though.
Okay.
So we went with B on that one.
Yeah.
Okay. Just want to make sure I was on the same page.
Wait, can Courtney hear us? Can you hear us, Courtney? Oh, did a little? Did you?
So we
see-
got 100%.
Oh, we did.
Yeah,
Yeah.
I turned it in.
Okay.
Got
Okay.
Courtney said that asked if we could start a new video.
Like, they can't look at the chat because they're not even looking at
We can hear her, but she can't hear us.
it. You know.
You can start a new video for the next one. I've actually had something come up where I've got to duck out.
Okay.
I've got another group project that just took precedence. Our due date just got moved forward 2 weeks.
Oh shoot. Oh,
Oh yeah,
it.
stop.
that's not good. Okay, yeah,
I'm gonna-
we can start a new video and then explain everything.
Well, it's just a review, so I can do that one on my own.
Okay.
So,
Okay.
good luck on the test,
Okay, thanks, you too.
and I will talk to all y'all next week.
Okay,
All right.
see you later.
Bye.
Goodbye.
All right, so who's gonna start the new one?
Well, can we start the same one?
I don't know.
Just all hang up and then,
And then push on that link again.
yeah, should we try it?
Try that, and then if it doesn't work, one of
I
us will
can-
just have to. Start a new
Yeah,
one
I can
and
start a new one. I can start a new one if it doesn't work.
push it to the chat. Okay,
Okay, sounds good. Okay, see ya.
and then keep this link so we can.
Yep, they ended.
Can you hear me now?
No, I don't have the phone number.
Can you hear?
Oh, I hear them now.
Is she still having a hard time hearing?
I think
Oh,
so.
I can hear y'all.
Oh, you can? Okay,
Yeah. Oh,
Okay.
it worked.
that's
I
good.
didn't know if y'all knew I was gone, so I was like, oh no.
I know we were like, is because I could like hear you talking, so I like thought you were like just coming along. Then I was like, wait, Courtney, are you there?
Oh, okay.
Anyways.
I didn't know y'all
Yeah.
could hear me still, so.
It was like kind of quiet though. So, anyways,
Yeah, it was faint. But
yeah, I could like hear you a little bit. I didn't really know what you were saying, but anyways,
So did you get the last of those questions, Courtney?
Some of them,
Lesson 14 one.
I finished it, but I didn't get it 100%, so.
okay. Which ones did you miss? We can tell you what.
I was gonna say yeah, because we did get 100% you.
I think it's the ones, yeah, like where it asks if you have sufficient evidence. I still
Oh.
like
The
get
last
so
one?
confused with those ones for whatever reason. So like question 15,
Okay.
yeah, it says run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F is 16.0474, and that P equals 0.000, with a level of significance equal to 0.05. What conclusion can you draw? So when it's equal to the level of significance, like which one is it?
P is a lot less than the level of significance, so that's what it is. If it's less than, then you reject it, and if it's more than it, then you fail to reject. So since our level of significance is 0.05 and our p-value is 0.000, then we have sufficient evidence to claim that at least one of the hot dog types has a different mean. Because in the end, all you have to prove is that just one of them is different. Not, it's either they're all the same or one or more is different. So
See, I put we do not have sufficient evidence to reject the claim that all 3 hot dogs have the same number of calories.
yeah. Because our null is that they do have the same, and then our alternative is that at least one is different, and because we're rejecting it, then it's that last one.
Okay. Okay.
This,
All right, there's one more. Hold on, though. I'm like, what is this? It's like the same thing, though. So I
probably the last one that was like the wording was so confusing.
Yeah, it's weird, worded weird.
Yeah, so 15. Yeah, it was the last one. So
So our p-value we found in the question before was 0.179, and that is more
greater than.
than 0.05. So because of that, so because it's greater, we don't have enough evidence. So it should be the second one. We do not have sufficient evidence to reject the claim.
Okay.
They word it so weird. Like it just
I don't like how that's worded.
Yeah, it seems like it's like double negatives or something.
Yeah.
like there should be an easier way to word that would make more sense. That's
Yeah.
what I. You have
Yeah.
to really read it and like pay attention to what it's really saying because it's.
Yeah, it's super weird. Okay, 179. All right, I'm just filling in the other answers now. Okay. So did y'all start on the exam one?
No, not yet. We were just getting ready to.
Oh, okay. Is Andrew here?
He had to leave for another group meeting, so.
Oh, okay. Right. Okay, sorry guys. All right.
These SPSS ones that I have, so I can not get confused to which one I'm using and just open them up when I need them. I get too confused.
I know it is confusing.
I have, like, there's too many things open up on my one screen. I need, like, 3 or 4 different screens to keep
I
everything.
know. 5 different computers. That would be so awesome.
I feel like I finally have a handle on this, but I get them confused and I can't remember like what equations go with what, or I don't know.
Yeah, well, it's funny because when I'm doing it, I'm like, oh, I get this, but then afterwards, I totally forget how to do everything. It's so bad. Okay. All right, so now we can go to lesson 15. Okay.
Okay. So I can do the first one if we
Okay.
well, I guess it's question number 2. But it says, given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? Thing that says is 90% of all people have a heart rate between 45 and 105. That one's not it. We are 90% confident mean heart rate is between 45 and 105. That one should be it.
Yeah.
It specifically says it is not a chance. Don't use that word. So.
Okay.
Way annoying they're in different orders.
Yeah, I found that last time we were doing our practice exam, I was like, wait, why can't it just be in the same order?
I
I know,
know.
because I just put like A, B, C, whatever, and I'm like, okay, now I'm gonna have to like go back and forth, but oh well.
Yeah.
Anyways, okay, I can do the second one. Do we
Okay.
want to read the whole like scenario, or do you guys know?
No, you don't have to do that.
Okay, so I'll just do question 3. It says, the researchers decide to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots for both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? And yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Yep, that's what I got too.
Yeah.
Okay, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? So I don't know. I have no idea. I know which one it's not because it's not the one that I put.
So it should be independent samples because they're not dependent on each other. The
Yeah,
boy,
that's
like
what I thought.
the male that is picked isn't linked to the female that was picked at all, like a husband and wife or boyfriend and girlfriend. It's just random males and random females. So it should be independent.
And the second and fourth one is only if you have one set of data, right? It's not
Yeah.
comparing. So the only ones that could be dependent is either dependent or independent. And yeah, like Charity said, they're not dependent on each other because they're just random.
Yeah.
Oh, okay. That makes sense.
Okay. So question number 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3,402 and 4142.75. Which of the following would produce a confidence interval, smaller margin of error than this 95% confidence interval? So I put obtain the balances of 90 bank customers rather than 30.
I
Don't
put
know if
compute 99% confidence interval rather than 95. Because
so it's one to have a smaller margin of error, right?
so in my notes I put your margin of error increases when your confidence interval increases.
Margin of error increases
Yeah.
in confidence level. Yeah, so that's like it's getting bigger.
Opposite. Yeah.
Crap, sorry.
Because I'm thinking like 95 is here, and then to 99 you're going out for numbers getting bigger. That's like how I think about it. Like if it was only like 25%, it would be really small. 95% is bigger, and then 99 is that's almost all of your data. So, but as you get more customers, then
Oh, yep, you're right.
numbers where more you become more of a normal curve, and so it just that's why I put that.
Yeah, you're right. I found it in my notes. Sorry, I didn't catch that it should be smaller.
Yeah, smaller.
Yeah. That's just how I like think of it, is I have to sit there because they're so confusing, those two things that is one gets bigger and the other one gets smaller, and then one gets bigger and the other one gets bigger with it.
Yeah.
That you're like, wait, which one is which? So I always just like imagine the plot there or the graph and how much data am I including into it. That like on the percentage, and that helps me understand.
Yeah.
Like visualize, okay, it's gonna get bigger if it's one. So
Okay, I can read this one. Well, do you guys want me to read the problem or just the question?
You can just read the question because we can see the problem.
Okay, so it says determine margin of error for this 95% confidence interval. So question 6. Sorry, I gotta go back and look. So I put. Oh wait, hold on. Sorry. What question is this connected?
So this is one I had a hard time with because I can't ever remember the equation where it's n equals whatever instead of m equals. So I was like, wait, I couldn't remember.
Okay, sorry.
So I thought this one was m equals though. I mean, I got it wrong, so.
We're trying to find not. Oh wait, are we
The
trying
margin
to
of error.
Okay, maybe it's the next one that I had a problem with. Let me bring up my
Wait,
questions.
it's not in order. I'm trying to find which one this connects with.
Is it not in order with the?
Oh, okay, wait. Maybe it is.
I think it is.
Okay, so I got 8.
8?
Oh, sorry.
A.
8.
Yeah,
No, 8.
99.
So 998.040. Oh, wait. What?
040?
Oh, these are like the confidence intervals.
Yeah. So your margin of error, I think, is 0.196, isn't it? That's what you're subtracting, right?
Uh,
I don't know.
oh, yeah. Yeah, it is.
So and it ends up being 1.96 because
2 divided by the square root of 4 is just 1.
yeah,
Okay, that makes sense, yeah.
this is the one I had a problem with. It's the next one.
1.960.
Yeah.
Okay.
Okay, so how did you guys get that?
So you have to go back to the equation and use x bar plus or minus t. Is it t or z? I don't know. Anyways, times the standard deviation over the square root of n.
Yeah.
And then you just plug in all
Oh,
those. You plug in all those. So if you're getting a 95% confidence interval, your z score, what is it? T value?
I think this one is T. I don't know. It's the same equation. It's just a different, like it.
I know. I'm like, I don't even know. Anyway, so the t would be 1.96.
Yeah.
So then when you put those in, I got the lower bound is 998.040 and the upper bound is 1001.960.
Yeah.
Is that what you got?
Yeah.
the lower bound is what?
998.040.
Okay.
And the upper bound is 1001.960.
Yeah, because
Yeah.
I used the right equation, I think. I just used the 2 times 2 over the square root of 4 instead of calculating what
Yeah.
bar plus or minus t. I didn't do that, so
Okay. Does that make sense though?
yes, I think so.
And do you know how we found the margin of error? Does that make sense?
Yeah, so in this one, the x bar would be 1000,
Mm-hmm.
Yeah.
and then the t, so you don't use the normal probability output then, you use the other one?
Yeah. So it's
Sorry, it's
given
gonna be
95%. It's always 1.96.
yeah. Sorry, it
So
is
it's 1.6.
the normal probability output that you use.
Oh, it is.
Yeah. Sorry, it is z. I always forget.
So, okay, I guess I'm really confused now. So you put 0.95 in the area then, right?
Yeah.
But when I do that, it says 0.063 for the
Yeah, I did that at first. You have to fill in the middle part, not the outsides.
Oh, okay, 0.95.
Because I did that at first, and I was like, "Oh my gosh, what the heck?"
Okay. Ooh. All right. Yeah, I get it now. Then. Yeah. Okay.
So if you go to the book, you can just memorize it, and it's just it gives you the ones for 90 and 95 and 99.9. That
Yeah.
way, like you don't have to do it every time.
Okay.
Or write it down in your book. You can like 95 because we use it the most. I know that one is 1.96.
Yeah.
Okay. Okay. Awesome. All right. I could do the next one.
Yeah, this is the one that I messed up on because I couldn't find the equation, and I knew like rearranging the other equation, but I couldn't figure that out. So
Oh yeah. Okay. I think I got it. So
it's instead of the intervals. So
yeah.
that's where I couldn't
So the
remember.
equation is n equals, and then in parentheses, z times standard deviation divided by the margin of error, and then you square all of that.
Okay, that makes sense. I don't remember.
Yeah. So it would be 1.960 times 0.01. And then you divide it by 0.0001.
Okay.
And then you square
See, it was all the equation that I had a problem with. I was like, I can't remember the dang equation, and I know what I'm supposed to do. I just can't remember.
Yeah.
Yeah.
I know there's so many equations.
Yeah. Okay, so then divided by 0.0001. So 196, is that right? Oh, I didn't square it actually.
Yeah. Square.
Oh, that's it. Okay. I was going, wait, because that's not one of the answers we were given, because I got the same thing, but I forgot to square. So 38 for 16.
Okay, cool. Yeah, because I did the right equation. I just
Didn't square it?
used the wrong information. No, I didn't use the
Oh.
like I used 0.063.
Oh,
instead
yeah.
of
I did that too. I did that too at first. And then I was getting like 40. I was like, what the heck? This is not even close.
See, I forgot that like I just went straight to the quiz and answered them in the quiz instead of using the lesson 15, which gave you multiple choice, which I should have
Yeah.
done easier.
Yeah, that's
Oh well.
true.
Okay. So we could just give the answers for them instead of reading the whole thing.
Okay.
Okay, so question 10. What did I put? Is the bottom one. Because it's smaller than, they're looking for less than, so.
Okay.
Yep. See, and these
Okay.
numbers are off too. It's way annoying. I'm like, I can't just be like, oh, look at number 10. I'm like trying to figure out this.
You have to match it.
Yeah.
Is it just number 9 though?
Wait, what?
In the book, is it just number 9? Because the first question we answered on the quiz was just like if
Oh.
we,
Yeah, I think that's what it is it's just one off.
yeah. Okay, who wants to do the next one?
Okay, I can do that one. It says in a statistical test of hypotheses, we say we reject the null hypothesis with the levels of significance alpha if is less than alpha.
Okay, sorry, I missed that. What are you guys on now?
The p-value is less than alpha.
We're on question 11.
Yep, that's good. Yep, that's what I got.
Okay, perfect.
So just the time that if null or something like that. Yeah.
Okay.
So
No.
So I got for this one, yes, it is enough that the data for each apartment building are bell-shaped with no outliers and the sample variances are nearly equal.
Yeah, that's what I got too.
Okay. Yeah. I'm just trying to read through it. I have to read through it to know where I'm at. It takes me a little bit longer to get to.
I know I keep having to like go back to my notes and then back to the other thing because they're different numbers. It's like what the.
Yeah.
Okay. Do you want me to just read it then?
It's easier for me if we read it because otherwise I'm reading it anyways and then I'm not hearing what you're saying.
Okay, I'll just read it then. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time for diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed a type 1 error.
Yep, that's what I got.
Okay.
Because she rejected it even though she shouldn't have.
Okay. 13. Is it my turn again? I can't remember.
Yeah.
Okay. So number 14, if the level of significance alpha is made very small, thereby making the probability of type 1 error very small, what probability of committing a type 2 error? Isn't it we increase the probability?
Yeah.
By probability of type 1, we increase the probability of type 2, right?
Yeah.
This is like the one thing that I kind of struggled with, is trying to remember all the errors and how they associate. So,
I know. I don't know. I don't remember that.
I think
So
it
just if
increased.
you
I like faintly remember that reading like one, if one of them decreases, the other one increases.
okay, wait, sorry. So it's number 1. I mean, it's A. By producing the probability of committing one type 1 error, we increase the probability.
Yeah.
Type 2.
Like,
Okay.
because I slightly remember that. So, yeah. I think that's what it is.
Okay. All right. I'll do the next one.
Okay.
So, okay, the nicotine content in cigarettes of a certain brand is normally distributed with mean and a known standard deviation. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measured on a random sample of 100 cigarettes of this brand gave a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypotheses. At the 0.05 level of significance, you could conclude that you should fail to reject the null, right?
No, that's not right. I took the quiz and that's what I put and I got it wrong. So it must be reject the null. But how do you determine that again? Like how do you calculate that?
What the heck? I was like so confident in that. So
I do that.
I think the equation Z, like, crap, I can't remember what it is. But I did 1.53 minus 1.5 divided by 0.17 divided by the square root of 100.
Okay, sample mean minus the mean
Yeah.
divided by this, what did you say again? Sorry.
The standard deviation divided by the square root of the population.
Square root of the population. Okay.
So then I got, for my Z-score, I got 1.765. And then, which makes the p-value 0.922.
1.53 minus 1.5 divided by 0.17.
So I get for 1.765, yeah.
Yeah. Oh my gosh. It's the outside ones instead of the middle, huh?
7.
But still, it's still bigger. It's 0.077.
So it should only be the greater than sign because of our
0.76.
alternative.
Oh, got it. Okay.
It should
So,
only be just that.
so the p-value would be 0.0388.
So 1.765.
Yeah, that's
Is that what you guys
Point
got?
0388. Yeah, which is less than 0.05. So then we would reject it.
Yeah.
Okay. Whoops, I did that one wrong. Okay, that makes sense though. So
Should we
you
reject HO?
yeah, reject it. Okay.
Okay, so number 16 says you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? And so it's going to be independent because they're random. Independent sample t-test because you're having two different groups and they're randomly selected. They're not linked to each other.
Okay. What is the paired samples t-test? Like, how do you know if it's that?
that one's like the dependent one. It's the same thing. Dependent and paired is the same thing. So it's like, okay, if you're gonna test the husband and wife, that's dependent because if you are testing the husband, you automatically know what the second
Who the
sample will be.
Okay.
So
If it's like random people, like males and females, then that's independent. Like they don't determine one another.
So like if you're thinking about paired, like for me, like I don't know, they still call it this, but they used to call it like being paired off if you were a couple. And so like a pair, like a couple, or they're related and somehow they're together.
Okay.
So like even if it's just like your like pre-test and your post-test scores, those are still related to each other. So that would still be the paired sample.
Okay. And then for the one sample z-test, is that when you know the standard deviation?
Yeah, Z is when you know because you get the Z score,
Yeah.
and then it'll be E score for the other ones. So.
One sample. Okay. I'm just writing this all down.
I get like so confident when I'm with you guys, and then I go to take it and I forget everything.
I know. It's so yeah, I have to be like in mode, be like, wait, what am I what anyways, it's kind of,
Yeah.
Okay, cool. All right, so the next one. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? So dependent, because if you select a brother, you must include the sister, right?
Yep.
Mhm. Okay.
okay.
Okay. Is it my
Okay.
turn?
I don't know. It doesn't-
I
Doesn't
think
matter.
Is it my turn? Okay.
I think
I'm gonna read this from the other one just because I have it. But is this a soil scientist?
yeah.
Okay, a soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. Dissolved organic carbon molecules are an important part of an ecosystem and help plants to process organic compounds. The researcher would like to construct a 95% interval for the mean dissolved organic carbon level in the field. Open the data and use this information to answer questions 15 through 16. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? So I said confidence interval for mu when sigma is unknown. Is that right? I don't know. I just guessed on that one.
Well, I think it would be one of the, oh, I don't know. Because there are different samples. It's not just one sample. So it wouldn't be that, right? Because that's only when you're only using one sample.
But if you open up the SPSS, I thought it was just one.
Yeah, there's only one group. So they're taking
Oh, okay.
several samples, but they're only measuring the one thing of
Okay,
like
then
it's
yeah. Never mind, you're right.
Like it's only one like they're compared against each other, but it's only carbon levels. that are being. So that's what I don't know. That's why I just guessed it. And it didn't tell us what the
Standard deviation.
standard deviation was. So I just guessed it was B. I mean, confidence interval where it's not known.
Okay.
Okay. Yeah, that makes
Too. I don't know. I just
That makes sense. No, that does make sense. No.
sense to me.
okay.
Okay.
Yeah, because they're not anything. Okay. That makes perfect sense. All right. So it says, which of the following is the 95% confidence interval for this analysis? Input your answers for the margin of error, lower bound, and upper bound. So the margin of error for this 95%. Let me bring it up.
So for this, you actually have to go in and look at it.
So does it ever calculate the margin of error for us, or do we always have to do that by hand? Because it kept asking that in the quizzes before, and I was like, I cannot find the margin of error anywhere in the data set or whatever.
So
Yeah, I don't know.
how I figured it out, I don't know if this is cheating, but it's basically the mean difference subtract the lower confidence. So like instead of having to figure it out by like the formula,
Yeah.
me and Andrew did it last week because we couldn't figure it out.
Well, you have to do the equation, but sometimes I'm like, okay, do I have to really go in and like figure out the equation? But does it work that way?
It did last week.
Wait, 1, 6, 8, 6.
We were sitting there going, wait, what do? We didn't know. And then after a while, I was just like, okay, I'm going to try this and see if this works. And it worked. So, because you're adding the margin to like the mean.
Yeah. Okay, yeah, that actually does make sense. So you have to add it or to subtract it?
It just depends. Pick one of them. I usually subtract it because then if you subtract it, then you'll have like, you'll just be left over with that number.
So,
what I
okay,
did
for
is-
example, so
Because
would you subtract it from the upper bound then?
okay, so yeah, that's you could either subtract it from the upper bound or subtract the lower bound from the mean. So either way, you got to subtract it. It just
It should be the
okay.
same.
That makes sense.
it should be the same either way
Okay,
because
so
it's adding and subtracting it. The mean is the one that's right in the middle. So
yeah, that
and make sure you don't. So the trick to do it this way though is make sure you don't round it too early because then it's wrong.
yeah, okay.
So you have to input all of those numbers.
Okay, so let's figure out what that is gonna be. Oh shoot, I'm trying to find my data for this is gonna be impossible. Holy cow. Okay.
So I got 2.076 because I have to round it at the end. And then, I mean, I say if we put it in there, the only problem is, oh, we do have,
Okay, I got something different. I mean, it's very close, but for the mean, it shows 13.19285.
yeah,
And then I subtracted the lower bound, which is 11.16833. And I
yeah,
got 2.02452.
Crap.
let me try mine again just to make sure.
So
2.192850 minus 11.16833. Okay, so you're right. What had happened is I pushed the wrong thing on the calculator. So 2.025.
Yeah, okay.
Yeah, I accidentally I pushed 2 instead of 5, thinking I pushed 5, and that's why I got
Oh, okay.
Okay, sorry. Well, I didn't hear my thing cut out.
Oh, so we just took the mean and then subtracted the lower one, and we got 2.025. 0.2452, but then you round at the third decimal point. So
Okay, perfect.
Okay. So then we
Okay.
have the lower bound and upper bound.
this is the easy part.
Yeah. So you guys
11.168
for the lower bound,
Point. Yeah, 168. Yeah.
and then 15.217 for the upper.
Yes.
Yeah.
Okay. Got it.
Okay. The next one.
I'm gonna close this first one before I start.
Oh yeah, yeah. We should do that.
I get so confused.
I know, me too. I'll like go on the wrong one on accident.
And then everything is wrong because I'm in the wrong set of data. So it's just easier for me.
Mine's loading. It's taking forever.
Mine does that too. Okay.
Okay. Whose turn is it again for the next one?
I can do the next one. Doesn't matter.
Okay.
So if we would, it says of the 4 types of confidence intervals listed below, which one is appropriate for the situation? And up at the top it says we want to know if there's a difference in mean listing prices between Hummers for sale in LA and Hummers from New York. That's group 1 and group 2. Percent confidence interval for the true difference of mean listing prices between the 2 cities. So we're looking at independent samples
Yeah.
because it's 2 different cities. They're not dependent on each other. We're just taking random samples from both cities. So,
Okay, then the next one is calculate the 95% confidence interval for the true difference of mean listing prices between Hummers from LA and New York. Input your answers for the lower bound and upper bound. Okay, so this one, since it has,
recode, right?
oh wait, no, it doesn't have to. What's the mileage? Okay. So you do the same thing, right? You go to descriptive statistics, then explore.
So before you do that, go to transform and then automatic recode and then put city in there so that it can separate your group.
Okay.
Otherwise it won't work.
Okay. So then you put that in the factor list,
Yeah.
and then you just put the price in dependent list, right?
So you put, well, okay, so go to transform and it says automatic recode. Push on the click down to city.
Oh, no, I already did that. I did do that.
Okay, that's what I was making sure. Okay, and then from there, do we still do the one sample t-test for this one? Or is it independent samples? But I don't,
Independent samples test.
okay. Always get mixed. Okay, so the testing variable is the price, right? We're looking,
Yeah.
and our city code would be define groups, group 1. What did it say group 1 is?
Group 1 is Los Angeles. Wait, is that what you're talking about?
1 and 2. Okay. I finally have it up.
Okay, that's nice.
All the steps. Okay, so the
So
lower
did you guys get the lower bound and the upper bound yet?
Okay.
yeah, I'm right there. So the lower bound is a negative number.
Yeah.
Negative 423.158.
That's what I got.
Okay, negative 422.15.
And then the upper bound. Oh, go ahead.
Oh, you probably got the same thing. It's 5,417.256.
Yeah. And we can close that one.
Okay.
Okay. Do you guys want me to read the next question while we get it up, or?
Sure.
Okay, it says many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 rats were selected at random for the 3 groups. A control group with no jumping, a low jump group, the jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks of 10 jumps 5 days per week, the bone density of rats, expressed in milligrams per centimeter cube, was measured. The data are recorded in the exercise bone density. Researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. So we're using the ANOVA test, which is that first question, because we have 3 different groups.
Yep. So then the next one says calculate the test statistic, and I got 7.978.
Okay.
Okay, I'm still getting that up. Let me down. Analyze, compare means. Oh, come on.
Okay, let's see. Nova.
That. And that. Okay, so let's calculate the test statistic. What did you get?
I got 7.978.
Okay, yeah, that's what I got too.
Okay. Sorry, I'm still looking at it because I couldn't even figure out what test it was. So I didn't even answer the next one. Okay. Compare means Villanova. Factor. Option. Okay. And the question was compute the or calculate the test statistic. Okay, so it's F.
Yeah.
Okay, and where do you find that again? Oh, it'll just say
You
F.
just keep, yeah, like just keep going down. It feels
Oh,
like
okay, so
you're down forever,
0.9.
but yeah.
Okay. Okay, cool. 978. All right.
Okay, and so the next one says to give the p-value. For that one, I got 0.002.
Yep, that's what I got.
Yeah, playing okay.
And then the next one says, which of the following best expresses the conclusion of of this test? Use a level of significance of 0.05. And I said there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Yeah, there is sufficient evidence. One group, yeah,
Okay.
because it is a lot lower than 0.0.
Yeah. Okay.
Does that
Next
make sense to you, Courtney?
Yeah, I did get that one. All right. So, yeah. Okay, so the next one. Pressures of supply and demand act directly. Oh, should we download that? It's, I forgot about that. Okay, do you want to proceed?
I was thinking that it was
Pull up, proceed. Okay. Okay. I'll just read it. Pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance, and then again 14 days in advance. The data are recorded in that. Perform a hypothesis test to determine if there is a difference in the mean cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of alpha equals 0.10. For the next 4 questions, do 14 days minus 90 days for the analysis. So what is the correct hypothesis test for this situation? And I said dependent samples test.
yeah, that's what I got.
Me too.
Okay.
Okay. Is it my turn?
Yeah.
Yeah, I think so.
So it says calculate the test statistic, and I got 1.685.
Okay.
Okay.
So sorry.
Let me
So,
figure this all out first.
so how do you calculate this one?
So it's, well, let's see. Let me see. Dependent sample. Hold on, let me pull my notes. I did it a little while ago.
Oh, so we want the difference between two.
Okay, so you do the wait,
Compute variable. So we want 90 days subtract 14 days. Is that right?
Well, no, you don't have to do that because they're in different columns, so you don't even have to do that. You just have to compute, you just have to put in like analyze, compare means, and then do paired sample t-test. That's it.
Oh, okay. Very simple t-test. And then you pull them both over. Okay.
So what did you do? Because I only remember doing this.
So, okay, I put variable 1 is 14 days and variable 2 is 90 days.
Yeah, I think that's right.
I'm not positive about that. But one of the answer that I got was one of the answers, so hopefully that's it.
No, I think you're right because it says, like when you pull it up, pair 1, 14 days minus 90 days, which is what he said to use. So I think that's
14
right.
days minus 19?
Yeah, 90.
Yeah, that's what I meant. So,
Yeah, and he tells us to in the paragraph above, he says for the next 4 questions, do 14 days minus 90 days.
okay.
So I think he always gives that to us. I think he always
Yeah.
tells us.
I think so too. I think we did a question like this.
I remember this. Okay,
like
and then okay, so let's see if I got this right. Okay, so calculate the T is, did you guys get 1.685?
Yep.
Okay.
Okay, then the p-value, that's 0.096 then.
Yep, that's what I got.
Okay, on this one, are we just making, is it like lower or greater, or is it just both? Just that it's not
Yeah,
equal to?
it's just different. It says, yeah, if there's a difference in the mean of cost of airline tickets.
Okay. So the next one, there is sufficient evidence to include as a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days.
Yep, that's what I got.
Yeah, I think that's right.
Because 0.096 is the low one.
Oh wait, no, that's. I guessed when I took the quiz, and I put there is insufficient evidence to conclude that there's no difference in the mean cost purchased 14 days in advance, and I got it right. So
Oh, really?
yeah.
But it's telling us to use a 0.1 level
Well, 'cause
as
we-
significance.
Because you reject the null, so
Yeah, I have no idea why it's that. Because again, I totally guessed. But
really, there's
So what?
there's insufficient evidence.
that there's no difference.
Yes, there's insufficient evidence to conclude that there's no difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance. I don't like how that's worded either.
Yeah, it's way annoying.
There's no difference.
Isn't that the same thing as what there is sufficient evidence to conclude there is a difference?
Yeah, isn't it?
That's so dumb.
I don't
Like,
really know.
it's saying the exact same thing, right?
I think so, but I don't know why he would put. both.
Why? Why would they do that?
Oh my gosh.
That's way annoying. But okay, well.
Yeah, that's weird. I have no idea. That's so weird.
Because it's saying the same thing. What?
Yeah, so
So both of them are right?
That's what I'm like. I wonder if both of them are right.
I don't know. Maybe they
One
all.
person put one and one person put the other.
I will put there is sufficient evidence just to see because
Yeah. Okay.
it doesn't make
It's
sense
the same
for me
thing.
to say
Yeah,
that.
let's see if they're both right.
I'm going to submit. And let's see. I don't know.
No, I did. I can't even take it again because I took one by myself. Okay.
Yeah, I'll submit mine because I just did it on paper before. So
Dang it. Question 5 we got wrong.
Question 5? No, I didn't.
I got question 5 right.
Oh,
Should
crap.
say
Did I do the wrong
balances.
one?
Did you click on the wrong
Question
one?
5 should be
Dang it, I put
obtain
10.
the balance of 90.
Crap. Did you guys do obtain the balances of 90 bank customers and rather than 30?
Yeah.
Yeah, 90.
Oh my gosh, I am so dumb. Okay. I meant to put that one, but I pushed something else. Okay, wow.
I hate when that happens.
That's like the problem with taking these online and having to go back and forth.
Wait, how is that possible? No, it is sufficient. You're right. It was sufficient. But how did I get that right on mine?
What the heck?
Yeah, I got 100%. There is sufficient evidence to conclude that there is a difference.
Yeah, that's so weird.
Yeah, mine's yeah, I got that wrong.
I know, but on my
That's
quiz,
so weird.
it clicked, but it says I got 1 out of 1 point. On the
That's
one
so
before.
weird.
So I have no
That's-
idea why it would say I got it right. That's so weird.
Creepy.
Okay. Well, no wonder it didn't make any sense because it's wrong.
Yeah, I was going, that doesn't sound right. I don't know. It was right. Okay.
I know, that's
So yeah,
Okay.
so
yeah.
we got 100% if you put them in how we went through it.
Yeah.
Okay, so I'm gonna need to
So
fix
funny.
my other one, but
Yeah, fix that.
other than that, we did good.
We did
Yeah.
it. Okay, awesome.
Now, if only we could take the actual exam together.
I know.
I wish that was just the exam. Why do we have to do enough?
I
know.
know. That'd be so nice.
Why put me through the pain twice? I don't understand.
It's a lot of questions, and it's like a lot of work for every single question.
Yeah, it really is.
It takes a couple
Yeah.
hours. But it's good practice. For me, when I did this, it helped a ton with the test. I was like, oh, this is easy.
Yeah.
So
Yeah,
hopefully,
super good.
hopefully we'll do well.
I know. Good luck, guys.
Yeah.
Hi.
Okay, well, is there anything else that we have to do, or is that it?
No,
All right, for
That's
the week,
it.
Okay, well,
I'll
we
Courtney,
leave stuff alone.
Courtney, do you mind posting those to the?
No, I'll post it.
Okay, perfect. Okay, well, thanks guys for your help.
All right, yeah,
Yep,
thank you
thanks.
guys. Have a
Okay.
wonderful day.
Okay, thanks. Good luck on the test.
Yeah, you too.
You too.
Bye.
Bye.